Any questions? Cool. So, looking at the first question, use the normal probability applet to find the combined area under the standard normal curve that is to the right of Z 1.358. 1.358.
So you're finding spot the part that's in the middle, right?
Let's see. Here, let me screen share.
Well, so you're doing number 3, right? To the right and to the left.
It wants to the right and to the left of that, so not in the middle. So it wants the edges.
So I see.
Yeah. So I have 0.175, right?
Yeah, 0.1745, so 0.175.
Okay. The United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. Previous value was lower, but was raised after a tragic boating accident. The standard deviation of passenger weights is 26.7 pounds. Weights of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme than was observed in this sample. Find your answer to 3 decimal places.
Okay, so do we have to use that equation, the Z equals value minus mean over standard deviation?
Let's see the weights. So the sample mean is 177.6, right? And so we're trying to find the Z value, or the Z score, right?
Yeah, so in the book, this says probabilities involving a mean, and there's the equation that Z equals value minus mean divided by standard deviation.
So it'd be 177.6 minus 185, right? And then divide that by...
And it says something...
26.7.
What is that? Character divided by the square root of n?
Yeah, so...
Are we using that in this case?
Yeah, so that's the standard deviation divided by the square root of the sample size. So the standard deviation is 26.7, and then we would divide that by the square root of 48.
Yeah.
So then I got a Z-score of negative 1.92.
Okay. 1.92. Okay, I don't have a calculator on me to check it. Okay, that's good.
Let's see. Is that right, Sarah? Is that what you got?
So you did... So what did you use for the value? Like the value minus the mean?
So the value is the 177.6.
Well, that's the sample mean.
Right.
Oh, so what's the actual mean?
So the mean
that's the 185.
Right.
Okay, so 177.6 minus 185.
Yep.
Divided by
26.7.
26.7 divided by the square root of 48.
Right. And so it wants wait, that is as extreme or more extreme, either above or below the mean. And so it says as extreme means that we are not only interested in values that are lower than the ones we observe, but also values that are as far away from the mean as ours in the positive direction. So basically what I'm guessing is that she wants the area like the same way of the last one.
So we put negative 1.92 into the z-score.
As a z-score, yeah.
And then what part is it?
To the left of the negative one and then to the right of the positive one. So I got an area of 0.0549.
Yeah, so 0.0.
And
so
Sarah,
0.055, right?
0.055, is that what they wanted, just 3 decimal places?
Yeah. Yep. After the 0.
Okay. Sorry, Sarah, I don't want to ignore you. I keep forgetting to look at the text thing.
Yeah, I just have it. I have it left up. Okay. Okay, are we pretty confident with that answer?
I think it's good. What do you think, Sarah?
I think that's right.
Cool. Alrighty. And then number 5, which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population?
Distribution of the individual observations. Won't it depend on the numbers or no?
Let's see. So trying to remember how to exactly apply this. Because the standard deviation is smaller when there is a larger sample size.
Yeah, because it says the standard deviation of a random variable is the standard deviation divided by the square root of the sample size, and the mean of the random variable is just u. What's that used?
Would it be the distribution of the sample means? I don't know what it means by distribution of the individual observations.
So would it be A?
My A is the distribution of the individual observations. Is that the same for you, Sarah?
Yeah. That's mine at least.
Yeah, that's what I have for my first one. So all of the data instead of just... So, yeah, what do you guys think it means by individual observations? I'm confused by that. All of the data, is that what you're saying, Sarah?
Well, she's saying instead of just the mean.
It's all of the data. Okay. Okay, cool. So, you guys just want to go with that one then, the first option?
Yeah. I think the next one is a central limit theorem. Not what yet.
I think that is the...
Right. What's
That is
called?
the law of large
Law of
numbers.
large numbers. Yeah, that's right. Decreases as the sample size increases.
Okay, so we need to find the z-score for her theme. Did you guys get a z-score of 1.05?
Yeah, I don't.
Places. Or 1.045.
I don't have a calculator on me. I'll have to check with Sarah.
Yeah, so I
just can't do it.
Cool, that's what I got as well.
Okay. So 1.045.
Yeah.
Well, wouldn't it just be 1.05 then if we're doing 3 decimal places? Oh, decimal places. Okay, sorry. Not characters.
And then, oh, so score above that one. So it'd be 0.148.
1.045.
I got 0.148 from using the normal probability applet, Sarah.
Yeah, it's just the spot to the right. Yeah, 0.148. That's what I got.
Let me put the screen share for my applet so that way Sarah can see. Cool. So, yeah, that's how I got this number.
So next one, a random sample of 5 students was selected to take GRE. Their scores are blah blah blah. So what does the z-score correspond to the sample mean of these students' scores?
Okay. So 160 plus
63.
49 plus I got 160 as the mean.
Okay.
So I just add.
Then do you just pick random one of the samples, or like how do you?
So that's the sample mean. What is 160 is the sample mean.
Yeah.
And so then we have to find the z-score of that. So using this information at the top, so it's 160. So the z-score should be the same. Wait, no, never mind. Sorry, it's not the same. So it's 160 minus 150.8. And then we divide that by 8.8 divided by the square root of 5.
Yeah.
And so then I got 2.338.
Okay, now we're going to put 2.338. And then it's asking greater than the mean achieved, so that would be 0.0097. Oh.
Did you see?
Oh, it's 4 decimal places. Okay, good.
0.337.
So I was like, that'll be hard to do to 3.
Okay, so 0.0097.
Yeah. And I'm sure that must be right because it's even saying round your instead of 4 decimal places, so that makes sense.
Cool. All right, so let's see. Suppose that the mean GPA of BYU Idaho students is 3.5. Standard deviation is 0.7. It's well known that this distribution is left skewed. A random sample of 81 students will be drawn. What is the shape of the sampling distribution of the random variable? 81 students are selected.
So it's just left, right?
Sorry, Sarah, 10 was this number. I'll type it in for you.
Oh, yeah. 10, 0.0007.
Yeah.
Okay. So is 11 just left skewed, or is it the opposite? I don't really understand that.
I think would it be approximately normal?
Oh, because the sample size is high enough?
Yeah. I mean, 81 seems like it's a decent enough number where we could get it to be not skewed as much.
Yeah, I'm not positive about that, but I remember if it gets high enough, then it gets normal.
So, I'm not sure.
Is there like a certain way to know, like if it's a certain amount, like a certain sample size or higher?
I guess like if we knew, well, so the mean GPA of BYU Idaho students. So if we're looking at the population of BYUI students, so 81 out of like, I don't know how many students there are, but let's just say like 15,000.
Yeah.
That's actually probably not a good sample size.
Yeah.
So then it would be left skewed. Or we just can't really know. I don't know.
Yeah, I don't know. Is there anything in the book about this?
So Sarah, you think it's normal? Okay. Not sure. Let's just move on.
It says the sample size is large and the central limit theorem implies that the sample mean is normally distributed. But it just says it is large. It doesn't really say what's large.
Okay. Then I feel confident enough to do approximately normal. What is the mean of the distribution of the sample means for all possible samples of size 81 that could be drawn from the parent population? Is the mean of the distribution of the sample means?
So what is that asking for? I'm kind of confused.
Yeah, what is the mean of the distribution of the sample means? Oh, that's true, right? Because the sample mean should be the same mean as the parent, so that would be 3.5. Yeah, I agree with Sarah.
Yeah, it says the parent population is normally distributed, so the sample mean is automatically normally distributed. I don't know if that has anything to do with it. It says that in the book.
Okay, so then the standard deviation would be well, the standard deviation is different, so it wouldn't be 0.7 because we have to divide it by the sample size, right? So there would just be 8, or it would be, sorry, it'd be 0.7 divided by the square root of 81.
Mm-hmm.
So then it should be 0.0, and then it wants, what is it, 3 decimal points?
Yeah.
Okay, so 0.077, or 78, sorry.
0.078?
Yeah.
What is the probability that the mean GPA for getting rooms will be less than 3.3? Okay, so 14. What is the probability that the mean GPA for 81 randomly selected students would be less than 3.3? Can you use the applet for that or no? I don't think.
Yeah, I'm not sure. Let's look at the. I mean, we'd have to find the z-score of that, right? That's the only thing I could think of. So yeah, we'd need to do that. Yeah. Okay, so then. So the value that we want is 3.3, and then we just minus 3.5, and then
divided by 0.7, yeah, divided by square root of 81.
Yep. So then I got a z-score of negative 2.7, and so
negative 2 point what?
negative 2.571. Yeah, Sarah. I got the same number.
Okay.
So then we want 3 decimal places, and so the probability is 0.005.
Wait, are we doing the less than? Yeah, so 0.005.
Yeah.
Okay. Oh, and now the next one's just greater than, so we just go back and select just the greater than one.
So then that would just be 0.995.
Wait. I got 0.0051. How did I get that again?
So the z-score that we got was negative 2.571.
Yeah.
And so if you look at my applet, am I still screen sharing my applet?
I'm on my applet and it's like giving me bad data.
Yeah, you want to, because the z-score is negative, that's the value that we want to look at above that. So it's everything above that line. So it's going to be 1 minus what we got for number 14.
Oh, so you include the middle area, I see.
Right, because it's everything above that.
Okay, so, sorry, what's the answer to 15 again? 0.99.
Let me type it, 0.995.
Okay.
That's what I put. Okay, we good?
Moment of truth.
Way to go, guys. I only missed one. So it's the distribution of the sample means. That's what we got wrong.
Oh, let's see.
Cool.
Bummer.
All right, guys. Till next week.
Okay, see ya. Thanks, guys.
See ya.